Hi everyone, myself Jyoti Prasad, Assistant Professor in Electronics and Communication Department, Armed Engineering College. Today I am going to discuss about actuators in IoT, like motors, servos and solenoids. So like we discussed in the earlier video, IoT sensors we have elaborated, and now I am going to elaborate about actuators in IoT. So both sensors and actuators are very important in the IoT or with respect to IoT in robotics. The sensors gather the information or observe the information or sense the information from the environment. So, but motors task is different. Motors based upon that data, the actuators will work. Why I am calling motors means actuators are different types: motors, servos, and solenoids. So, like an electrical motor only, here the three things all the three things based upon the size, application, the actuator type will vary. Actuators are essential component in IoT systems. The conversion will be input output. What is the input to actuators? What output will be provided by the given by the actuator is nothing but converting electrical signal into physical actions. So, for example, say the sensors, temperature sensors have taken the readings from the environment. It's a high temperature. Then what actuator will do based upon the input provided by the sensors? Actuator will get the electrical signal, like for example 45 degrees centigrade. That particular time the fan should be switch on, so it will give an electrical signal to switch on the motor or a fan. So that will be converted into physical action. So the input for the actuators is from electrical signal, so that will be converted into physical action by switching fan or rotating the fan, so with a high speed, which will cool the temperature. So likewise, it will convert electrical signal into a physical action. So input is a electrical signal, output is a mechanical action like physical action. So actuators enable devices to interact in physical world by performing like task moving, positioning, or controlling the flow of materials. So depends on the environment or the requirement. So motors, servos, solenoids are common types of actuators. What we are using in IoT applications are application of IoT in robotic and automation systems. IoT actuators are mechanical and electromechanical devices which turns energy into a motion, that is a physical action. So they combine the combine electrical signal with energy sources, ultimately manipulating physical world around them. How IoT actuators will work and what are the applications. Like I told you, here is a block diagram. So it is step by step process. Like I said, sensors will sense the data from the environment. So sensors will gather data and send it to IoT controller. So in the second block, controller, there is a decision maker. So the controller transmits the electrical signal to the actuator in the third block. So the actuator interprets the signal and translates into physical moment. That may be motion, linear motion, or circular motion, or anything. So that will be converted into a mechanical action. So this process is a straightforward one. So sensors and actuators put together, they will work through IoT controller. So what's the difference between sensors actuators? Like I said, sensors will sense the data or observe the data from the environment, and measuring temperature like detect sensor technology. But that will converts into that will give it to controller, sense the data and give it to controller. So the controller will decide what actuator will do means the electrical input got from the controller, that will be converted into mechanical motion or in action. So here electrical signaling is nothing but actuators use heat or motion energy to perform action. Conversion direction, how conversion direction will be, the actuators turns electrical signals into physical actions. This is the direction. What is the inputs and outputs? Actuator will have follow machine outputs while sensors capture environmental inputs. First we will see about the first type, motors. In actuators, first type is motor. So motor will convert electrical energy into mechanical motion. So here, like we have studied in electrical engineering, there will be two parts, rotor and Stator. So stator is a stationary part, rotor is a moving part. So when the current flows through motor windings, it creates a magnetic flux. Then the rotor able to spin. So how many types of motors means what we using in IoT? DC motors, direct current motors. They used to use for simple designs or a stepper motor. So this will have a discrete steps and they are very suitable for precision, precise positioning, like 3D printers, CNC printers. So these type of equipment we are using stepper motors. AC motors, which will well have bulk in size. Alternating current motors are used for high power applications and continuous operations. Whereas in robotics, how we are using means motor driven robots for automated tasks, or conveyor belts, robotic arms. If the robotic arm movement has to be left, right, or up and down, that motor should be rotate. So there we are using the actuator or motor. So like we have told in the industrial electrical motors are connected to the axis points through the controller, IoT controller. They will change the directions based upon the inputs. Servos. Servos, if you see here, so servo, see here, so this is a servo. So based upon the direction of that particular module will be changed based upon the input. So servos is a small self-contained motor. In that case, self-contained motor will be there, which includes feedback control to achieve precise angular positions. So here the position has to change means this servo motor, this angular change has to be done based upon the input. The angular change will be done. Will be it uses a positional sensor to ensure accurate positioning. So standard servos will be there, so which will have typically only from 0 to 180 degrees of alignment. So they will have continuous rotation. So what are the components in servos means it will have a motor which will provides motion and a feedback mechanism and a control circuitry. So this is the thing how we are going to control the servos. So based upon that particular input from the controller, IoT controller, we are going to change the direction. The third one is solenoid. Solenoids are the mechanical action electromechanical device which converts electrical energy into linear motion. So linear motion means when current passes through a coil, it creates a magnetic field. So that will pulls or pushes the plunger. So if we want, we will show the picture. We will have a better idea. So here the wall plunger will be there and plunger will be there. So this blue highlighted one. So when the magnetic field is induced here, then either pushing that rod up and down. So based upon that, it will work. So when current passes through the coil, it creates magnetic field and that will pushes or pulls. So it will push and it will pull back. So there are linear solenoids are there and rotatory solenoids are there. So what will the provide means linear solenoids, they will provide linear motion, push and pull, whereas rotary solenoids provide rotation. Where we are using these solenoids means locking mechanism. So smart locks are there, electronic door systems. So in that, so based upon the input, it will push that particular lock, plunger. Okay, so that will pull and push. So then it will lock. When it will pull back, it will unlock. If it pushed, it will lock. If you pull back means it will be unlocked. So whereas in valves, we will be used in valves where HVAC gas systems are there, gas flow control systems there. The gas has to be released, has to be locked. That time this push pull mechanism closes the gas flow and opens the gas flow. So actuators, so used in automated machinery for pushing pulling mechanisms. So based upon our applications, we want to choose the actuators which one we want. So